Hello everybody. This is a part 2 to lesson 7, titrations. Today we're going to be focusing more on the lab skills associated with titrations. Before we get started, we're going to go over lab data analysis one more time, and then we will go over procedure and lab skills that are associated with this. So here we have a lab data table from a titration. Today you're going to learn how this data table is created in a lab. But let's go ahead and read this. So review, determine the concentration of sulfurous acid with this titration. So they did a titration of 35.5 milliliters of sulfurous acid with 0.85 mole per liter NaOH. First thing we're going to do is determine the volume added. Now, the volume added, is this the volume of the NaOH or the sulfurous acid? Because we know that this is the titrant, the volume added is what's coming out of the burette. So the titrant is in the burette. A burette looks like this. It's on a stand. And then we have our flask. Hold on, and then we have our flask. Looks like that. Okay, so in here we have titrant. We know the concentration of titrant, and we figure out the volume by collecting data, the initial volume and the final volume on the burette, to see how much volume was added into the sample, into the flask. So we start off with the sample in the flask, and then we add titrant into the flask. So the volume added is of our titrant, so of our sodium hydroxide. How we do this is we always go final minus initial. So this would be 20.1. This would be 20.3. This one would be 21.1. This is 20.3 and 19.9. From here, you're going to see which ones are going to get eliminated. So if we're eliminating, we want to select values that are 0.0 plus or minus 0.2 of within each other. So far, looking at those numbers, I would say that these three are 0.2 within each other. The way that I do this, I look for ones that are very similar to each other. So since these two are the same, those are good to keep. Then I see, are there any others that are close by? Well, this one here is minus 0.2 of that number. So that eliminates trial 3 and trial 5. Now we're going to take the volume average. So the volume of the titrant is equal to the volume average of those three numbers. So that's 20.1 plus 20. It's not how you write a 20. 20.1 plus 20.3 plus 20.3 divided by 3, which gives me a number of 20.23 milliliters. Okay, make sure you have the units correctly. We are working in milliliters. From there, we're going to write a balanced reaction. So we have sulfurous acid reacting with sodium hydroxide to produce sodium sulfite and water. Okay, it's a double replacement reaction. From here, we're going to balance. There's 2 waters and 2 sodium hydroxides. We're going to list all of the information that we know below. There was 35.5 milliliters of this acid, and we're looking for concentration of this acid. Here we know the concentration is, we know the volume added was 20.23 milliliters, and the concentration is 0.850 moles per liter. Right. We're going to begin with what we know, which is this guy here. So let's begin writing our Stoich. 20.23 milliliters. The only reason I'm using milliliters is because both my volumes are in milliliters here, and it'll end up working out. If they are different, you need to convert them into liters. If you are uncomfortable, you can then go ahead and convert both of them to liters. Okay, so from there, we are going to convert this into moles. So I multiply by 0.850 moles per liter. Okay, liters cancels out with liters. Oh, I forgot to write, this is NaOH. And I have millimoles. The base unit is moles, so I can now use my mole ratio. I divide by 2 moles of NaOH and multiply by 1 mole of H2SO3. Okay, moles cancels out with moles. NaOH cancels out with NaOH. The last thing we need to do is divide by our volume, which was 35.5 milliliters. Milli cancels out with milli, and we are left with moles per liter of sulfurous acid, which gives me a concentration of 0.242 mole per liter of sulfurous acid. Okay, so on the burette, we're going to be reading a meniscus. So this is how a burette looks like. You have the numbers and they increase as they go down. The reason being is because the volume drains from the bottom, so the scale increases towards the bottom. So in this first one here, I see that my meniscus is kind of laying right on that line. So what confuses students is because the scale is going downwards, they'll often mix up how they read it. So if it's above, it's going to be below 20. So this line here is 29. This line here is 28. So I would just say it's right below 28. So that's going to be, I would say, like 29. I would say that that's about 29.1. It gets right about to turn to 28. Oh, sorry, not 29.1. Yeah, I would say it's about 28, approximately 28 milliliters, because it's like just below that line. Okay, for the next one, I would say that this one, so this is 9, 8, 7, and 6. That bottom of the meniscus is hitting relatively close between the center of 6 and 7. So I would say that this is about 6.5 milliliters. The next one, we see that it's clearly hitting between two lines. We need to figure out that line. So this here is actually 45, 46. Sorry, we're going backwards. 44, 43, 42. So it's in between 42 and 43. So this would be 42.5 milliliters. Okay, the last thing that you guys are going to do is I have linked a titration video below or on D2L. Click on that and you will watch it and write a brief procedure on how to perform a titration.